Let's look at a case of a car or a bike traveling over a hill. So I just have a hill. I'm just driving my bike along, and I go up over this hill. Right, it's kind of like a ramp. Obviously, here I am in my fancy bike, um, and if I go too fast, I'm going to jump. Right. I don't know if I can draw a person actually on the bike. There you go. Fancy. Um, so if I'm going too fast over this hill, then I'm going to end up like just leaving, right? I use it as a launch pad or a ramp. If I go, really slow, it's basically as if I'm just sitting here. And so one of the things that we can do is we can think about what happens right on the top of that hill. So right when I'm up here, what's going on? Let's ask the question about the person. Let's say some given parameters. Um, let's say that this is, I don't know, maybe a 20-meter radius hill. So it's like a big circle of a radius of 20 meters right when I'm on top. Um, let's say I can ride my bike at about 10 meters, 15 meters per second. I don't know. Velocity of 10 meters per second is how fast I want to ride my bike. Let's say that I have a mass of 100 kilograms and my radius is 20 meters. All right, what am I going to feel if that's the case when I'm on top of this hill? Right? So let's just do the physics. Free body diagram. I know that I'm going to have my mg pushing down and I'm going to have the normal force pushing up. My coordinate system, my radial tangential coordinate system towards the center of the circle will be positive. So I'm going to have my coordinate system radially positive in this direction. And then the sum of the forces radially, I get mg minus Fn equals mar. And I know that that radial acceleration is v squared over r. So I end up with mg minus Fn equals mv squared over r. Or if I'm actually interested, and if my question was, what do I feel? I'm going to say that I feel Fn is equal to mg minus mv squared over r. And now we can just plug in a few numbers and see what happens. So I said my mass was 100 kilograms, 9.8 minus 100 times velocity squared over radius. So I'm going to get 980 minus 100 times 10 squared divided by 20 minus 500. So I'm going to feel 480 newtons worth of force. You might ask, like, okay, so there's a number. How do I interpret that? What does that normal force feel like? Is that a lot? Is that a big force? Is that a small force? I can compare that to myself right over here. What's going on over here? My free body diagram over here is mg Fn, and I have a regular coordinate system. I'm not in a circle over here. Sum of the forces in the y direction. Fn minus mg equals may. And in this case, nothing really is going on in the y direction. So normal force equals mass times gravity, or in this case, mass times gravity is equal to 980 newtons. So my regular, what I feel on the bike seat here is 980 newtons. What I'm feeling over here is only 480 newtons. So maybe I want to compare, right? And the way we're going to compare is we're going to just make a ratio. What are you feeling compared to what do you regularly feel? 480 over 980. Is going to be 0.49, so basically 0.5. We're going to call this 0.5 G's, this ratio. I feel about a half a G. 1 G is what I feel regularly. I'm feeling a half a G, so I feel a little bit lighter. I feel like I'm being lifted up out of the seat a little bit. The second question might be, well, that's kind of interesting. If I feel a little bit lighter, how fast would I actually have to go in order to actually sort of float, in order to leave my seat, to lose contact with the ground. So if that's the case, we can ask that question pretty easily. I can pull this equation right here, right? My normal force equals mg minus mv squared over r. But when I am floating, when I've left the ground, my normal force is 0. So I'm looking for the case when mg equals mv squared over r, or in this case, since my masses go away, that's irrelevant. I'm looking for a velocity equal to the square root of gr. In this case, square root of 20 times 9.8, my velocity of 14 meters per second. So at 14 meters per second, that's when I float. That's when I lose contact with the ground. If I'm going faster than 14 meters per second, I'm launched. If I'm going slower than 14, I'm going to feel somewhere between 0 and 1 Gs. And if I'm stopped, I'm going to feel 1 G. So this is an interesting problem about going over the hill and how we can think about radial acceleration in those cases.